Thank you to all of our speakers, and we're now going to head over into our Q&A session. So Graham, would you like to take us away?
Thank you very much, Bree, and thank you very much, Steve. And huge thanks to all of our speakers. There's one thing that strikes me about how all of these projects, the challenges that they've met, comes together. We've heard about material efficiency in Tristram's airport roof. We've heard about site logistics and the challenges that John was figuring out solutions to. People and complexity, and Sean talked about helping people, informing people, and allowing people to install really quite complex structures. And Hannah talked about the extending the utility of an existing building and saving carbon in the process. And Steve talked about the challenges of essentially saving weight to protect those existing columns down in the crypt, and the solution was to make everything work much harder and achieve greater material efficiency. And then you saw some fabulous hand work, the Barugo finishing on those stone pieces which had been machined. So the question I really like to ask all the panel to respond to is really about this influence of people and the site assembly processes, because there are questions about people's site labouring jobs. There's the question of, does all this digital technology displace people? Does it reduce the quality of people's work on site or their experience? So I'm going to start with Tristram. Would you care to address that question of how all this influences people working on site?
Thanks, Graham. And of course, it's very hard to predict exactly what influence anything has on the future. The future is a very difficult thing to predict. But just a sort of big picture, if we step back, if we think of our population, growing from 7 billion to 10 billion, if we think of the urbanization, which I'm going to assume for the sake of this argument continues in a post-pandemic, and we think of the rising living standards around the world, we will have to construct more city than currently exists over the next 30 or 40 years. So to me, material efficiency and ultimately carbon friendly materials, are sort of ahead of the queue of things to resolve. And on the other side, you've also got, in some countries, a shortage of skilled labour. Actually, the labour force on sites is getting older and no longer necessarily available to us all. So I can't predict, and I'm not a contractor, so luckily I don't have to predict, what's going to happen next. But the other reflection I'd have is in my 40 years in the construction industry, we've used computers to analyze structures, and we used to talk about going to a 3-day week. Back in the 80s, we thought credibly, we'd be working only 3 days a week. What actually happens is people have worked harder and harder, and we've used the new tools to do things that we didn't think were previously possible, as opposed to, reduce the amount of time taken by any individual. And I love the Sagrada story ultimately, which shows that some combination of technology and craftsmanship and natural materials gives you just a phenomenal outcome, which people experience. It lifts their souls when they experience it. It will stand, I think, the test of time, and therefore, fits the circular economy model. And ultimately, that's what it's all about. It's about people doing what they each individually do best and making the most of the resources available to us.
Thank you, Tristram. So let's. You mentioned Sagrada there, so I'm going to jump to Steve. And how does from your experience, how is it these techniques changing the experience of people in the design team and the construction team?
Well, the thing that I thought of when I was hearing Tristram speak, and in general in this discussion about the work that people do, the opportunity that we have using digital fabrication is to reimagine the work that people do, and do it slightly differently. So the jobs on site are different, but we can make them safer and more satisfying and more effective by using machines to automate part of the process and to help with the construction. So I think we'll be moving to an industry which is more productive, produces more beautiful things, and allows people to work in a safer and more satisfying way.
Thank you, Steve. And Sean, you showed us some fascinating augmented reality techniques. How has that changed the experience for those actually placing materials and for the contractors and others in that environment?
Yeah, I think it makes a huge difference, because traditionally the documentation, as I pointed out with that sketch of a reinforcement drawing, that every sketch that we produce, every drawing we produce is an abstraction of reality, and moving away from that into a more data-rich presentation of what is to be built just makes it far easier for people to consume. And coming back to your point, Graham, about people, the one common thread with all of these presentations, and common to, I guess, some of the most satisfying projects I've had the pleasure of working throughout my career, is when we've had the opportunity to engage with the people who make stuff. One of the biggest challenges, I think, in our industry is that designers and makers are kept a long way apart. We don't get the chance to talk and collaborate with each other, but every one of these projects had some significant input from people who made things, or in the case of the Aboriginal houses, the people who are going to live in them as well. So getting that input, I think, is absolutely critical. And although we might be cutting pieces of material in a slightly different way, we're still heavily reliant on real craftsmanship and the thinking that goes in behind that.
Thank you, Sean. And Hannah, you talked about a project where you're able to reuse the concrete bowl that Tristram designed many years ago and extend its life and make it much more comfortable for people to use, and mean that it gets much more utility, much more utilization now for all sorts of events. And a different way of working right through the design and fabrication and installation. How did the contractors and those taking on the design work that you were doing and building it, what was their response? How did they benefit from that way of working?
Yeah, definitely. Given the type program that we were under, as I mentioned, the shop detailers sat in the Arup office, and it was a very collaborative approach. And because we gave them the 3D models, they were able to overlay these models with their Tekla models in order to ensure that the geometry of all of these complex connections was accurate. And that made it a lot faster for them, and it was a lot easier for them to kind of get their heads around these complex connections. So overall, it wouldn't have been possible to meet the tight deadline without delivering them in this way, and without the collaborative approach that that we had with the shop detailers.
Fantastic, thank you. And John, many of us have never, myself included, never experienced working in the tunnel environment. And you mentioned the challenges of not being able to turn around large objects. The approach that you talked about of scanning and making things to fit. There are two questions that come. How do you think that approach would influence the experience of those building in that tunnel environment, and what obstacles might there be to bring in those benefits to them?
Well, there's a whole set of challenges in there. Deceptively simple looking object, deceptively simple looking things, but the challenge is to put them together in a very tight program, because it usually is a tight program, All the time has been used up in constructing the civil works, the float is gone, and now the rail systems and the fit out has to happen quickly. And as we know from reading the newspapers, civil engineering projects with tunnels can go wrong at that point. It's usually not about the hole in the ground, it's the fitting it out afterwards. So it's really about program. And some of those decisions are very strongly driven by program. The cost of 3D printing of one piece of material versus what a fabrication shop produces it becomes immaterial when you look at the massive overheads on a large project, which are measured in time. So I hope that illustrates the point. It's all about time. Now that's new build. If we then talk about the dominant feature of life for most operators and owners of infrastructure, and that's maintenance. And there it's operational continuity. If you stop the railway for 1 hour, you pay massive business continuity charges amounting to millions in only a few hours. So it's vital to have methods of working for replacements and refurbishments that are really quick. And that's where these techniques come in.
Tremendous. Thank you, John. And Tristram, I think you also talked about how things fit together, but you've other responses to this question.
Yes, I think that one aspect we haven't talked about yet is the reduction in waste, and the benefit this brings to construction from a climate change and carbon perspective, but also just efficient use of resources. So the two aspects I think I didn't fully understand when we started doing this 15 years ago was the accuracy you can get, and of course that's because 30-40 years ago we drew things that were approximations. We even put do not scale on our drawings of whatever it was we wanted, and the builder had to work out as they went along how to make things fit together and what sort of accuracy was actually required on site. Now we can start with a design model that is millimetric accurate, that can describe exactly what we want, and therefore can move to digital fabrication as the next step, which has these two advantages to me of, well, three: speed, accuracy, and very little waste.
Tremendous. Thank you very much, Tristram. So thank you, panel, for responding to that series of questions. But we've some fabulous other questions and challenges from the audience. So Bree, you've been looking at those, and I think you have some to pose to our panel and to other guests who have joined us in the speakers room.
We do. Thank you, Graham. So we've been discussing the potential and indeed the active practice for digital fabrication across a range of sectors. And one of the key questions that we've had from the audience is, what are some of the enablers that are helping us to start to bring this to market and start to move into broader practice? So perhaps first we can throw to one of our experts who we have in our presenters room from our Hong Kong office, Ramon van der Hitten. Now, an associate director with Arup, he is the Hong Kong Digital Design and Service Leader, formerly with Front Inc in Hong Kong, working as a computational design specialist. And he works together with architects, contractors and fabricators to realise some really quite extraordinary projects. So, Ron, from your perspective, what are some of the key enablers that are helping us to introduce these digital fabrication practices?
Oh, thank you so much for that wonderful introduction. And well, I believe there's quite a few, and I'll try to just kick this off with my personal thought. At first, when I think about digital fabrication, it's easy to think about machines, right? It's about 3D printing, CNC cutting, and it's about multi-point form machines, etc. But especially looking at the breadth of presentations that we've seen here today, it seems actually that digital fabrication is in its essence, it is about data management and data processing. And Tristram already just touched on it just now in saying that when we are designing now, when we're designing in 3D, we are actually designing much more explicitly than we have in the past. And that's what digital fabrication is about as well. It is about explicitly defining what something has to be. Because that's what a machine needs ultimately. But when you're able to explicitly define your design, for it to be able to made by a machine, actually you have all the information needed for anything or anyone to be producing it. Where I'm getting at with that is that the most important thing is, in being explicit, recording the data about your design, not just as geometry, but as actual data that is structured so that it can be interpreted either by human beings or by machines. And so this structured data needs to be made available to those who need it in the formats that they will need it, and that will also enable collaboration as well. So structured data in accessible locations would be, in my opinion, one of the key enablers for digital design, digital fabrication.
Thank you for that. Now, does any of our other panelists want to weigh in on that question? Sean, perhaps from your perspective, when we've been talking about...
I was just about to jump in. Thanks, Brie. Yes, I think just to add to Ramon's point, which I completely agree with, it's understanding how people make things and what platforms and data sets they need. So completely aligned with Ramon's point there. And in a couple of the projects we showed you, so the project in Queen Street with reinforcement design, excuse me, and augmented reality, and also Hannah's tennis centre, both used Tekla as BIM platform. And Tekla has been used by the steel industry for decades as the software they use to order, cut, manufacture, deliver and erect the steelwork. So it's making the data as consumable as possible and in the format that the maker wants to receive. Makes a huge difference.
Sean, are there any particular projects that come to your mind in terms of thinking about where this has worked particularly well, other than some of those that you've spoken to us about today?
Yeah, there's a couple of projects that immediately spring to mind, both of which were delivered without any drawings, or at least maybe just one drawing. So the first one is actually in Melbourne. It's the Travellers. So if anyone's familiar with stainless steel figures that cross the river near South Bank. That was, again, absolutely following on from a discussion with the manufacturer, and we're talking to them about how they wanted to receive the information. Actually, they consumed it far more easily via an Excel file than any kind of drawing. So a little pretty picture in Rhino and an Excel file, and away they went and made it. The other one is in Sevilla, in southern Spain, which is, I think, still the second largest timber structure in the world, which I think that was still I'm trying to think of it, Metropole, yeah, the Metropole Project, which was a huge timber structure which was delivered as a Rhino file. I think there was one set of drawings, or one drawing actually, showing the connection principles, but the entire geometry, and it's pretty complex geometry, was delivered entirely in one Rhino file. And again, that was easy for the manufacturer to consume and then make the pieces directly from that.
Thanks, Sean. And Steve, I think from your perspective, was there anything that you would like to share in this space around around how we might communicate in terms of that flow of information between the makers and the fabricators?
Yeah, absolutely. The files and the data are utterly important, and they need to be there for transferring numbers. We also, at the same time, need to make sure that we communicate to the people, and so ways that people come to understand our design. And Sean showed us ways of doing that using augmented reality and immersive headsets and stuff. I think that creating drawings is also a very powerful way of making pictures of our design that people understand so that they can comprehend it. So as well as the data, we also need to do a communication piece with the people who are responsible for making and producing and so on. So I just wanted to mention that.
That's fantastic. Tristram, was there anything that you had to add from this? It would be great to get your perspective.
Well, I think it's also about the early stages and deciding how you're going to deliver something, and that's all about collaboration. So it's about working with your client to work out the best way of procurement, Ideally getting the people who are going to make things on board as early as possible so we can resolve all the issues we've just been hearing about, the detail of how the data has to be transferred, etc. But the thing I just want to stress is you have to all do it together. This isn't about any one organisation or one individual. This is about teamwork and about team understanding of what we're trying to achieve and how best to achieve it.
Great, thank you for that. We had another question that was around cost effectiveness. So would anyone like to take a question around, perhaps John, from your presentation, you were talking about some really fantastic new approaches that were coming in for new materiality, particularly with the marine project, etc. Are there any potential barriers in terms of cost effectiveness and bringing this to market at scale?
I think this is very material dependent. I showed a project which Sean actually worked on, which was the stainless steel bridge, footbridge in Holland, and clearly no one is pretending that a stainless steel bridge is cheap or that 3D printing it was a cheap way to do it. It was a challenge and it proved the point, and it achieved regulatory recognition. But that's just like starting to melt the iceberg. When these things happen more at scale, then I think industry will understand better where the advantages are. It's never going to be cheaper, viewed in a narrow sense, to use more sophisticated tools to fabricate things that could be done simply. But as soon as you get on site, if you've got that better tolerance control, you will save weeks, months, and lots of risk in a program critical environment. So, for instance, in the tunnels example and the brackets, one of the most interesting points there is that the biggest single element of cost in the civil works bits is the logistics, and that includes the risk allowances for things going wrong because they don't fit. So if you spend more money but you make them fit, you save time, and that is a crucial element in many infrastructure projects. I hope that illustrates the point.
That's great. Thanks, John. And Graham, I believe you had another question that you wanted to pose.
Yeah, I just wanted to, picking up John's point there about time, and I noticed there was a question from the audience to Hannah about the tennis stadium. About that there, Hannah, you had a very compressed time scale. You had 12 months overall. Was that 12 months for construction, or was that for design and fabrication and everything? I think that was the question.
Yeah, so the 12 months was for everything. So we commenced the design in January, and from the start of the project, we had a couple-week period where we were doing digital inception reviews and whatnot to kind of figure out the best way that we could achieve the deadline. So we had 12 months until the opening event. That meant that the existing structure had to be demolished and reconstructed and commissioned by January. So it really left the design time to be quite short. We only had 4 months to actually design the roof. And yeah, so from January to April, we designed the roof, and then the rest of the time was the construction and the commissioning of the roof. So that the first kind of couple of weeks was very crucial in terms of planning and having discussions with the stakeholders as far as how our delivery would be. And that's when we talked about having the shop detailers in our office in order to streamline the process. So those conversations had at the very start of the project, and those decisions were made very early on.
Thank you. So that process in developing that design, you were collaborating with the contractors who were going to install the works, and those who were going to fabricate it, and making sure that within that overall 12 months there was time to design and fabricate and install and bring all that together. Yeah,
exactly. The fabricators had very early on involvement. They were in the original meetings. Fabrication, who were the lead roof contractor, we collaborated with them from the very beginning. in terms of how to construct the cable net, how to build it, how to fabricate it, whatnot, and that all helped us with our design. So it was very collaborative from the start.
So this touches on Ramon's point that working in this way, everything is very much more explicit, in that you were working hand in hand with the fabricator's detailer to make sure that those details were absolutely explicit and could go straight into manufacture without somebody else having to reconfigure them.
Yes, exactly. Yeah.
And Tristram, you mentioned being able to put together these precise components without adjustment, and Sean has shown how humans can be enhanced with the augmented reality to be able to understand and get feedback on placing things very precisely. I'd like to pose a question to Goman Ho from the Hong Kong office. Would you, from your work on high-rise buildings, for example, what do you think about this question of humans assembling things or robots assembling things? Often people say, well, if it's difficult or complex for a human to do it, we should give it to a robot. What's your feeling on when that might happen and whether that's a desirable way to go?
Well, I think, of course, we see that there is a change of having more robot for construction because the increasing demand in offsite fabrication, right? And try to make it to increase the buildability and so forth. And all this will be a lot of member now being done offsite. And because of that, you have the condition or less constraint of using robot, less constraint. And so robot will be is probably like a change. And you can see that some of the factory now doing prefabrication or precast member are actually really robotic, right? From formwork and casting, and they use the BIM, whatever whatever request of concrete, there is no wastage at all, right? Because they have already counted the volume of the panel and also deducting the volume of rebar, right? So I will see that in the coming future, there will be more and more robots, adoption of robot or robotic construction, right? And also some of the, I understand some of the tunnel site now also has a robot to do the installation, because in the tunnel, basically the dimension are typically constant in some way. Yeah.
Thank you very much, Goman.
Yeah, thank you.
Good point. And Andrew has also joined us in the speakers room. Bree, what other questions have you seen from the audience? I know we've had some good response there. Perhaps you can answer another one of the questions rather than one of mine, please.
Absolutely. We've had some really interesting questions that are speaking to a lot of the presentations that we had talk to sustainability. So they talk to how we can start to move beyond a basic level of green design towards regenerative design, how we can start to use different modes of digital fabrication to move us closer to longer term sustainable futures. So I'm wondering if any of our panelists, perhaps Steve, if you wanted to, or John, if you wanted to share a little bit about how you see some of these processes moving us towards spaces that are using less materials, that are creating less waste.
I am fascinated by the idea of being able to make our geometries so subtle and slim that we can use very much less material. I see the Catalan vaults, the tiled vaulting roofs at Sagrada Familia, and it makes me think of the magnificent things we could do with concrete if we could make it into such subtle and beautiful shapes. At the moment, we cast it in sort of pretty thick, flat slabs, don't we? Because that's simple to assemble the formwork. But if we can fabricate it digitally, then that gives us an opportunity to reduce material use and thus reduce carbon very significantly. We're at the beginning of that road, aren't we? We're just making the digital techniques work at the moment, but that's an exciting opportunity for the future, I think.
And thanks, Steve. If I could add to that from another angle in the infrastructure field, I would say that one of the most exciting things for us is the learning that we get from better use of digital models and digital data. The data-rich environment gives us insights we never had before. For instance, even a simple thing like looking at the BIM model quantities for things in a tunnel surprises you by how much concrete you're throwing into things like solid mass concrete walkways. I was amazed to discover that on a project I'm on at the moment, we have 44,000 cubic meters of the stuff just in the walkways because there's so many kilometers of them. And that causes you to think, wait a minute, that's a lot of carbon. There must be a better way. Until you got the data, you didn't realize what you were missing. So I think we can all learn a lot from the data that we have, and that's even today's technology. Once we put algorithms in to help us, we'll go further.
Thank you, John. And that thinking about that data and about the impacts of those materials, Tristram, I know you've done a lot of thinking about the materials that are in existing buildings, the materials that are going into our buildings we're designing now, and what might happen to those materials at the end of their life or when they need to be modified. How do you think all of these techniques follow that agenda?
Thanks, Graham. A very complicated question, but of course, so far we've been talking mainly about reducing material consumption in new construction, but our needs would be even better served if we reuse our existing buildings and or pieces of infrastructure and or then recycle the components thereof before we even commit or think about building new. So this is, of course, the goals of the circular economy. And the first thing we can do right now is for everything that we design or interface with or go and measure or assess is to create material passports for everything that already exists, because then we will have ideally published in an open source database. So then we have access in the future to knowledge about what we already have and what we can reuse and recycle. This is, it's not exactly digital fabrication, but it links through to the same idea as Ramon was talking about earlier about having data and models which are accurate and have all the information in them, not just of things that we wish to construct, but things that we already have.
Thank you. Thank you, Tristram. Steve, what the way you've described constructing Sagrada, for example, that all seems very modular in a sense. Do you think that I can't imagine a church of that scale being demolished and reused in our lifetime, but how does that thinking sort of impact on that sort of project?
The project has been in existence for, the building has been in existence for many years already, hasn't it? 130 something. And my sincere hope is that it will continue to be in existence and giving people joy and spiritual nourishment and delight for hundreds of years into the future, and so that it will be sustainable because it is itself, and that's something that carries on being. I don't think that we're imagining that the modules of that building will be taken apart and built into something else. I don't think that would be appropriate. Digital techniques do have a magnificent they have a magnificent ability, don't they, if we are reusing building supplies, for us to be able to, and this is a next step, isn't it, for us to be able to catalogue those reused components and bring them into new construction in a way that we can't do at the moment, because we can't imagine all the existing pieces. But if we could find a way of measuring, cataloguing and distributing existing building materials that have been taken out of buildings, that's another opportunity to use digital techniques to reduce our carbon impact.
Thank you, Steve. Now, John, you have a long and illustrious career all over the world, building all sorts of projects, not just tunnels. So, if Tristram's posing this idea of, everything that we build, everything that we survey, can we give it a materials passport? And as a materials person, that really resonates with me. I would love to know what everything is made of and how it was made. From some of the projects that you've worked on in the past, what's the information that you would love to have available and kind of easily transferable to others who might be able to reuse parts of those structures?
I think it is this big data. It is the not just the existence of certain materials, but how many of them and what their life is expected to be, because then we can look for ways to reuse them. So to give a simple example, people may have seen on some news outlets in the last 6 months articles about graveyards of wind turbine blades. There are literally thousands of them already. As they come to the end of their fatigue life, these materials are a very high grade composite, either glass fiber composite, or some even have bits of carbon fiber in them. And the notion that all we can do with them after deconstruction is to grind them up and use them to make waste paper baskets or something is a bit pathetic. We really should do better. That's an example of where we ought to be looking at incorporating those pieces of those blades, reconstituted into parts of other new structures, because they potentially still have a very good design life. But the starting point for that is knowing that they exist. Until 6 months ago, it had certainly never occurred to me that there even was a graveyard of wind turbine blades. So we're now looking actively into how to use them on new build.
Thank you, John. That's a fascinating new source of material and opportunities to use what, as you say, is high grade material.
And of course that's a sort of opportunistic thing. I think more in a more structured way, owners of big infrastructure possess large amounts of materials, and totally agree with Tristram that they should have a passport. Some of the more progressive clients are starting to try and adopt those ideas, and it's not easy. But if we want a planet to be around for shape for us to live on, for our grandchildren to live on, we need to get on with it.
Exactly. Thank you, John. And there's some interesting questions about education and about the fact that these new techniques are emerging quickly. A lot of them have emerged fairly recently. Most of them have emerged since I started work, and many of us. So there's a question really about education, and I know all of our speakers are involved in one way or another with educating other engineers. What do we think is changing? How's the challenge changing in terms of educating engineers about manufacturing processes and construction processes, and as we shift into this environment where those processes are continuing to change. It's not like the days when I was educated. I was kind of anticipating that those ways of making things would be the ways to make things forevermore. And we're now in an environment where that is changing constantly. Steve, you teach structural engineers regularly. Are you seeing this change happening in the educational sector?
Oh goodness, there's a question. We used to think about new materials all the time, didn't we? When we graduated, Graham, it used to be this is going to be the new material for the future, and now we think in terms of the new digital techniques that are coming. Yes, it's so important to get the engineers of the future thinking about what they're making and how they can make it, and to understand the materiality and the reality of what they'll be making, as well as the digital end of it. And as an educator, in a small way, I think one of the most important things that we do is to engage people in that real world, which is something that at university they're not directly engaging in, are they? They're doing a thinking thing. So that's kind of the way we focus our efforts.
Thank you, Steve. And Tristram, I know you've thought a lot about this question and about getting people to be curious and creative and properly engaging with the things that they're designing, making.
Yes, I think, Graham, that comes round to the from our perspective at least, for the industry, for us to change our requirements that we place on the universities and the way they're educating people. At the moment, we demand so-called shovel-ready students, people who are already capable of being put to work the day that they walk in the door. To do that, they have to fully understand current codes, regulations, materials, what we're using today, and that then becomes, the backbone of the syllabus. But I think actually the world changes faster and faster, if you like, as more and more capability and technology becomes available to us. And so my suggestion would be that we educate more people in general and embed the right attitudes, if you like, towards curiosity, working out what we can do, thinking about whole projects, integrating multidisciplinary approaches, including how to construct things, and then learn what you do on a day-to-day basis more when you've actually joined industry than what to do in the classroom. But I think the fault is not with if there is a fault indeed, is not with the educators, it's with industry demanding that everybody's, you can make money out of them the day they walk in the door.
Thank you, Tristram. I think that very important point about how we have to become more flexible.
So perhaps just before we finish up today, one more question, and Ramon, it would be great to hear from you again. We've had some questions from the audience around how design and fabrication can play a role in an uncertain future. Obviously, we are now in a time of accelerating change, perhaps far faster than any of us could have imagined. How are we seeing design fabrication and the potential for digital fabrication helping us to make better decisions in a time that we are increasingly uncertain?
Oh, thank you for that. So it's a big question, and I don't really know what the future has in store for us. But what I can do is share an anecdote. In one of my previous projects in a past life, I've worked on a very large fabrication job for a facade. And at that time, we had an uncertain future as well, because we knew that we had to design this facade system to a very high level of detail for a fabricator, but we didn't know who the fabricator was going to be. so we made sure that we designed this system in such a way that we had data available for every element, and that we could reformat that data into whatever visualization necessary. We were imagining this to be digitally fabricated by CNC and machines, but when we met with the fabricator, they said, well, actually, we just need to like throw a lot of people at this to get this done in time. It's going to be a lot of manual work. So at that point, we said, how would you like that information presented to you? And we basically went through every part, and they said, okay, so we need a CNC cut file for this. We need a drawing for this. We need a check drawing with dimensions for this. And we went back to our huge database that contained all the information about the design. And we just did a data engineering exercise in taking the data and formatting it into whatever was the format that they required. Could have been augmented reality. In this case, it was a lot of drawings, but in having all that data stored in a database, we set ourselves up for an uncertain future in that we could have machines produce it, or we could have people produce it, or it could have been anywhere in a city or anywhere in rural areas. So that would be my take on it.
Great. So the idea of using data to help us make more intentional choices and the capacity to start understanding how we might shape broader forces by building these data banks from a range of different projects.
I would say yes, it would set us up for flexibility. We could represent that data in whatever format is appropriate for the time.
And I think flexibility and adaptability is something that is so key for us at the moment, and certainly something that we've heard discussions about today, whether that's the flexibility of being able to work differently together, whether that's the flexibility to actually adapt our assets or our practices of working, and indeed to work in more productive ways with the environment. So that's actually bringing us to the end of our panel session today. We hope that you all learned something, both from the presentations that we had earlier and from our fantastic conversation we've just had now. We hope that some of it inspired you. If there are any other questions that you have, we'll endeavour to respond to you. So please, if you haven't shared your name, please feel free to send us through an email through the link that's in the chat box, and we will get back to you. We'll also be sharing this recording, so that will soon be dropping into your inbox. And now, to take us to a close, back to Graham.
Thank you, Bree. And thank you very much to all of our speakers today: Tristram, Carl Frey, John Batchelor, Sean McGinn, Hannah Lazenby, Steve McKechnie, Goman Ho, and Ramon van der Heide, who joined us in the speakers room here. And thank you, but thank you to all of you who've joined Arup for this event today. Really appreciate your time and your questions and engagement in this debate, and we really look forward to talking with you further, and for continuing this journey of adapting to these new techniques, just learning how to reconfigure the techniques, imagine how we use them in the future, and just imagining smarter ways to develop and use our built environment. It's been a great pleasure to hear from everybody today, and stay safe, and look forward to talking to you all in the future. And thank you very much, I must say, to our production team who've held all this lot together. Thank you all, and goodbye for now.